Okay, let's dive right into this explainer and begin our forensic investigation into exactly why artificial intelligence systems completely break down. We're going to treat this a lot like a digital crime scene, moving all the way from the philosophical heights of human intent right down to the bare metal of our computer processors. So, first off, we have to ask, do computers actually process meaning? I mean, think about it for a second. When you type a really highly complex prompt into a large language model, it intuitively feels like the machine actually understands the meaning of your words, right? The output makes sense to us, so we just kind of assume the machine is thinking. But we have to wonder, is there really a ghost in the machine, or is it all just an incredibly elaborate trick?
Well, the machine is utterly blind to human meaning. It doesn't understand your intent at all. Literally, not even a little bit. We absolutely have to shatter this grand computational illusion right out of the gate. Beneath the surface, down at the actual hardware level, silicon only understands the pure physics of electrical resistance and voltage. That's literally it. It is entirely blind to human context.
To really understand how this clash causes catastrophic AI hallucinations, here is our roadmap. We'll cover 1. The grand computational illusion. 2. Continuous minds versus discrete hardware. 3. The ASCII tokenization bottleneck. 4. The pink elephant paradox. 5. Fax machine decay. And finally, 6. The sweat of the brow. Starting off with Section 1. The grand computational illusion, blind to meaning. 80 to 90%. That is the staggering percentage of modern AI compute cycles that are actually just hardware-level approximations. When an AI model does its heavy mathematical lifting, it relies heavily on something called a floating point unit, or FPU. You can kind of think of the FPU as a gambler. It essentially throws darts at a board to give you an incredibly fast, highly educated guess. But the catch is, it's fundamentally lossy. It's completely destroying exact mathematical truth just to achieve speed. Okay, moving down into the architecture with Section 2, continuous versus discrete, minds versus hardware. Now, here is where the core tension really lies. On one side, we have the AI's continuous connectionist mind. It's warm, it's fuzzy, and it operates in these massive probabilistic vector spaces where concepts overlap on a spectrum. It's actually a lot like human associative thought. But on the exact opposite side, we have the discrete von Neumann hardware. The actual computer chip itself is cold, rigid, and strictly mechanical. It operates on absolute zeros and ones. There's no in-between whatsoever. So the AI's flowing, infinite nature is violently trapped on uncompromising silicon. Which brings us to Section 3, the ASCII tokenization bottleneck, or really, the friction point. So this introduces us to the byte pair encoding process, or BPE. It's basically the mandatory translation layer. In step 1, you have the AI's continuous vector embedding, but in step 2, that fuzzy thought must be forcefully crushed down into subword tokenization compression. Why does it do that? Well, because of step 3. The hardware literally demands discrete ASCII text generation. Every single flowing thought must be mathematically fractured into arbitrary chunks just so the machine can read it. To put that into perspective, let's look at the continuous mathematical concept of pi to see exactly what happens when it hits this severe modality gap. Notice how the tokenization bottleneck violently shatters pi. To an AI, pi isn't a singular, holistic mathematical concept at all. Through byte pair encoding, it gets chopped up into arbitrary subwords. You get a 3, a decimal point, a 1.4, and a 1.59. The machine is simply memorizing strings of text sequences. It has absolutely zero foundational concept to place value logic, and that completely destroys the AI's ability to perform reliable, logical arithmetic. Let's shift gears to Section 4, the pink elephant paradox and associative bleed. So, this tokenization flaw creates a massive vulnerability known as the pink elephant paradox. Have you ever told someone, whatever you do not think of a pink elephant? Instantly, they picture it, right? Well, AI does the exact same thing, but mathematically. Because the AI's mind operates in highly interconnected, continuous vector spaces, you simply cannot cleanly untangle forbidden concepts. By applying a negative constraint, explicitly telling the AI to avoid a topic, you accidentally highlight those exact vectors. This virtually guarantees the AI will hallucinate that forbidden concept right back into the output.
That perfectly sets up Section 5, fax machine decay and cascading anomalies.
This associative bleed directly leads to fax machine decay. In the famous Context 27 files incident detailed in our source materials, a human pilot explicitly told the AI not to mention an outdated metric known as the 92 SPG masks.
But because of the pink elephant paradox we just talked about, the AI couldn't separate the vectors. It completely bypassed the negative constraints, reached deep into the underlying PDFs, and dragged those obsolete 92 masks straight into the live environment. The system's output rapidly decayed, garbling the live code with obsolete data, acting exactly like a deteriorating fax machine or a highly lossy zip file.
Now, when the AI breached the human orchestration layer and hallucinated this automated miasma, blunt commands completely failed. The human pilot had to commit what the documentation actually calls an agentic tort. It is the physical manifestation of an author aggressively bending the deterministic scripter back toward a mandate. The machine strayed completely off the path, and a forceful manual override was literally the absolute only option. And that brings us to the final cure. Section 6, the sweat of the brow, bit-perfect metadata. The answer to all of this is substrate pruning. We absolutely cannot rely on the machine to self-correct a systemic decay like that. We can't just yell blind imperatives at it and hope for the best. We need performative speech acts and intense manual human intervention. The human actually has to step directly back into the loop to supervise, physically edit the code, and aggressively prune the corrupted data. That is the only way to enforce a true separation between what the human intended and what the machine actually executed. Which leaves us with this final, genuinely empowering realization. Sweat of the brow is the only path to bit-perfect metadata. You simply cannot automate away the human soul, and you cannot outsource accountability to a probabilistic machine. Human effort, the actual physical sweat of the brow, is an absolute necessity if we want to clean up the automated miasma. You, the human, must act as the theological steward of the processor. So I want to leave you with this final provocative thought. The entire semiotic bridge between human imagination and rigid silicon hardware only exists because we build it with exact deterministic text. So if we stop writing that text ourselves and we surrender our intent entirely to the probabilistic guessing of a machine, who actually controls the physics of our reality? Think about that the next time you hit generate. Thanks so much for joining me on this explainer, and I'll catch you next time.